Hello everyone, this is Rashida. Welcome to my channel. I introduced gradient boosting algorithm a few weeks ago where I explained how it works in details step by step and implemented the model in Python's scikit-learn package. Today we are going to work on XGBoost, which is extreme gradient boosting. This is another popular implementation of gradient boosting algorithm. And this is in fact a much improved version of the regular gradient boosting algorithm that we worked on a few weeks ago. If you haven't watched that video or if you are not too familiar with gradient boosting algorithm, I encourage you to go and watch that first because it is always a good idea to learn how the machine learning model actually works. It helps decision making and also it gives you an edge in an interview. So what is special about XGBoost algorithm? Why we needed XGBoost after gradient boosting algorithm, right? XGBoost algorithm includes regularization. If you're not familiar with regularization techniques or the concept of regularization, for now just know that regularization helps in preventing overfitting. We will talk in details on regularization in a different video. It also can handle null values. Very important aspect of XGBoost is it can use multiple cores or CPUs for faster computation. Also maximizes the uses of available disk spaces, so it is highly scalable. You can use terabytes of data and it can handle that. And it provides feature importance scores that helps to understand which features are more important for your dataset. Okay, now we are going to implement a classification model in XGBoost. And we will talk some more in details while we are going to develop that. So today I'm using a Google Colab notebook. If you use a Colab notebook, at least for this practice, you don't need to set up XGBoost in your Jupyter Notebook environment, or if you're using an IDE. Here I'm using this multiple disease dataset and I have this dataset uploaded here. Okay, you can use this to actually upload the dataset. And you can see we have all these health parameters, and towards the end we have this disease column and here I'm checking for the null values in the dataset, and you see we have no null values in any column at all zeros. And here, how many diseases we have? We have total of 5, actually not 5, 4. First one is healthy, and then the other 4, those are diseases. And because those are categorical variable, I am making them numeric here, so it will come out to be 0, 1, 2, 3, 4. Now we define x and y here. X is the training features. That is all the columns except for the disease column. And our target variable is the disease column itself. Here, I'm using train test split method from scikit-learn library to divide the dataset into training and testing portion, and I am keeping 20% of the data for testing. All right, let's dive into the model. First, from XGBoost, import XGB classifier. And then let's define the parameters. The first parameter I'm going to choose objective. Objective is going to be reg logistic. Let's show you the parameters, okay? Here you can see the documentation. Okay, please feel free to go through this documentation, understand it better. You can see these are parameters here. I'm going to show you this GitHub page. On this GitHub page, it is documented pretty well. And if you notice, it actually have all the parameters and explanation what is what. Okay, this is the objective. It determines a loss function to be used in the process. For example, linear for regression problems. Not only linear, there could be other loss function available, and reg logistic for classification problems with only decision, binary logistic for classification problems with probability. And you see alpha, that gives us L1 regularization, lambda, it gives us L2 regularization. So you can choose to use alpha or lambda, which one works for your model. Learning rate, if you watched my gradient boosting algorithm video, I explained in detail what learning rate is and what it does. The max depth, it determines how deeply each tree is allowed to grow during any boosting round. Okay, call sample by tree, that is the percentage of features you want to use for each tree. Then n estimators is the number of trees we want to build. I have the link in the description box below for this GitHub page and also this documentation page. Please feel free to explore some more. So let's choose our parameters. Okay, so for objective, I'm using reg logistic. And max depth, I'm using 5, alpha of 1, learning rate 0.1, and n estimators. You have seen me using n estimators in random forest, in AdaBoost, or gradient boosting. So n estimators 90. XGB, so XGBoost classifier, so let me showing here, and I will pass these params here. XGB dot fit. So the model is here. We passed the parameters. Now all we need to do is to pass X train and Y train, our training data, to the model. And the model training is done. Let's see the accuracy, okay? XGB dot score X test, Y test. 1. So 100% accuracy. What can be better than that? Let's see in the training data as well. X train, Y train, 100%. So perfect model. Please feel free to try different data set and with different kinds of parameters, different values of the parameters that we have used here, and see how it works for you. That's all for today. If you like this video, please like, comment, share, and subscribe. Thank you so much for watching.